Okay, so this is the program that I'm using for the oscilloscope. The window behind is the function generator. The window in front is oscilloscope. So the red one is what do you call it? Well, I was actually interfering with it just now. The red one is channel 2, and the blue one is channel 1. And channel 1 is input, channel 2 is output. So hold on, let me just let me auto set this. Okay, that's actually kind of weird. Wait, let me just make sure. This is, that makes no sense. How is channel 1 weaker? Okay, so channel 1 is crap, right here. Channel 1 is this probe right here. It's traveling. Okay, so it's connected to that right there. And I know that channel 1 is blue because it's blue right here, and channel 2 is red right there. In fact, I'll turn off channel 2 so that you can only see channel 1. Okay, I know why one was bigger than the other, because one's at 0.3 and one's at 1. So I'm gonna make them both at 1. There you go. And now I'm gonna turn this one back on. Okay, that's still pretty weird. Shouldn't be doing that. Hold on, let me just auto scale again. Okay, up here I'm going, okay, it's still kind of weird. I don't know why. It's not free energy, because, you know, this bulb actually looks maybe slightly brighter than that one. Like, it's about the same, but I would say, you can't tell from the camera, but I would say the transmitting is slightly brighter. And like I said, there are some weird interferences. Like, I'm going to put my hand near there and you're going to see the graph changing. See, like, I'm touching the transmitter and the receiving graph is changing. Okay, anyway. Let me, here we go, waveform parameters. It's already open. Where is it? Okay. This stuff is not faulty, by the way. I'll show you it's not faulty afterwards. Okay. So what do we have here? Channel 1. Oh, wait, what's the frequency? Okay, let me change the frequency to 3.85. 385 0000. Okay, that should be right. And it's square wave. Okay. What frequency is it measuring? Okay, channel 1 is kind of whack. So channel 2 is measuring 3.85. Channel 1 is measuring a different frequency. Maybe if I move away. Or you know what? Maybe it's oh, it's not. Okay, give me 1 sec. Okay, I figured out what was wrong. It was this switch here, I guess, did something. It was down here. I moved it back up, and the waveform is bigger. Let me just check the parameters again. Okay, there we go. So both frequencies are matching. Channel 1 has 3.85 and channel 2 has 3.85. Let me turn channel 2 on though, because that was from the previous result. There we go. So both at 3.85. It's still kind of weird to me why. Okay, wait, we'll find out for sure here. So channel 1 is input, remember, and channel 2 is output. So channel 1 is receiving and channel 1 is transmitting and channel 2 is receiving. DC mean is same, max. You know, you can just look at the stats here. Min is here. Min for receiver is greater, so is max. Peak to peak is greater for receiver. the high and the low. Okay, amplitude, RMS. Okay, so receiving is greater. You know what? That's actually kind of weird. So as you can see, the receiving has more. There's some sort of excess energy. I'm assuming maybe it's collecting other radio waves and it's strengthening. Duty cycle here 49%, so it's off by 1%. Down here, I don't think this stuff really relates to the problem, but you can look at it anyway. Yeah, so I don't know. I find it kind of weird how. But you know what? Okay, one thing we can do is we can turn this one off and measure. See what we measure. So I'm gonna disable this right here. Disable it so that there's no more pulsing, and you can see it's off. The lights are off there, off, and right there, off. Okay, so now we can see what it's picking up exactly. So right now it's really small, so let's auto set it and see which one's more. Alright, so channel 2 is receiving, it's receiving, I don't know, I guess random waves, and channel 1, hold on, let me turn off channel 2. Channel 1 is not receiving very much. I guess maybe because it's all the way in this corner. So that excess energy that we saw was just probably from radio waves, or just man-made waves. Have a wireless router somewhere there. I doubt it's the router though. It's probably just radio waves and whatnot strengthening it. Let's look at the parameters and see what we see. Let's auto set it one more time just to be safe. Okay, it's still auto setting. Okay, so wait, still auto set. Still auto setting. Okay, I think it's ready now. Let's see what it says. So channel 2 has more DC mean, but we're not really caring for that. Max is more for channel 2, min is more for channel 2. Peak to peak greater, channel 2 is greater. Looks like everything is greater for channel 2 except this right here. The decibels. But the RMS is greater. So I don't know. Some things are greater, some things are not. I'm actually not too sure. Like I think this is decibel, but I don't know how to like translate that to what I don't know how to. And it's not giving off. It's not showing a specific frequency because it looks like it's constantly changing. But they're at the same phase, I guess. So they're out of phase, but by the same degree. So yeah, I think the excess energy is just from random waves, because we have man-made waves all around us. So yeah, that's basically the experiment. Oh, okay. Maybe I should show you what happens. Hold on, let me turn it back on. So let's put it back to square wave, or was it sine wave? I think it was sine wave. Just to be consistent. Well, okay, fine. We'll put square wave because we get more power from that. Okay, let's auto set this. Oh, I forgot to enable it. All right, enabling, and oh boy, it's frozen. Too much happening at once. Okay, there we go. Let's auto set this.